Hi guys, welcome to Chemonics online digital classes. Here I am your Pawan Kumar. Chemistry with the DPK sir is very easy. Dear students, are you struggling to distinguish the aromatic compounds, anti-aromatic compounds from the non-aromatic compounds and all? You don't worry guys, here I am your DPK sir. I will help you how to identify the aromatic, anti-aromatic and non-aromatic compounds in the most easiest way here. Okay, let us see without wasting our time, okay, what are all these types of the compounds here. Dear students, my kind request, please be focused to listen the class here. Okay, take a paper, pen and keep on write, okay, without having any disturbances. Listen the class. I am very sure after the class you will be guys the master to identify the aromatic, anti-aromatic and non-aromatic compound. Easily you can do that here without using pen and paper. Okay, easily you can answer within 5 to 10 seconds. Okay, let us see how to do this and all here. So for that, first you need to know some basic information about these aromatic compounds. You know guys, actually for first time who identified the aromatic compounds means the aromatic compound first time benzene is discovered by the scientist Michael Faraday in the year of 1835. Okay, right. So generally the word aroma is here now, it is derived from, okay, the aromatic word is derived from the word aroma. So aroma means it's a pleasant smelling, good smelling, sweet smelling compounds here. Okay, so but it is not exactly correct here. Why? Because there are so many organic compounds like esters which are very sweet smelling compounds, but all the esters are not aromatic compounds. Then how to identify the aromatic compounds means based on their properties we are identifying the aromatic compounds here. Generally guys, you know, aromatic compounds are those, okay, which are having the highest percentage of the carbon and hydrogen atoms, and when you subject it to the flame test, it gives a yellowish sooty flame here. So the aromatic compounds gives a sooty flame on the flame test here, okay, with the yellow colored sooty flame it will give here. And generally aromatic compounds are participates in electrophilic substitution reactions and sometimes the nucleophilic substitution reactions also. So based on all these characteristic properties, now let us see how to identify the aromatic compounds here. So if any compound is to be aromatic or anti-aromatic or non-aromatic, there are some rules, okay, which must be satisfied. So let us come to know what are those rules here in detail one by one here. So first let me tell you what are the rules to identify the aromatic compounds here. Okay, so those rules are called as aromaticity rules here. Okay, which rules are guys here? So these rules are called as aromaticity rules here. What are these aromaticity rules? Okay, let us enjoy these aromaticity rules here. So actually guys, there are the 4 rules. Okay, what are the 4 rules you know? So first thing is that the compound must be the cyclic compound. Aromatic compounds are the cyclic compound. The second rule is that the cyclic ring must be the planar ring here. And third rule is that all the atoms of the planar ring must have the continuous conjugation without any break. This is third rule here. And these are the 3 rules which are common for the anti-aromatic compounds also. It means aromatic compounds and both anti-aromatic compounds are the cyclic compounds. They are having the planar rings and all the atoms of the cyclic rings are having the continuous conjugation. Then what is the difference between the aromatic and anti-aromatic compounds means the aromatic compounds are having 4n plus 2 conjugative pi electrons, and whereas anti-aromatic compounds are having the 4n pi electrons here. That's all simple. And what is a non-aromatic compound means the cyclic compound which is neither aromatic nor anti-aromatic will be non-aromatic compound here. Okay, so neither aromatic compound nor anti-aromatic compound, that cyclic compound is called as a non-aromatic compound here. So if you know these things, it will be really very easy to identify the aromatic compounds. Now let me tell you all those rules here in single statement. I will try to write them all the 4 rules of aromatic compounds and anti-aromatic compounds here one by one. So let's see what are aromatic compounds means. Aromatic compounds are those, okay, which are a cyclic, okay, planar conjugative rings. Okay, cyclic planar conjugative rings containing 4n plus 2 conjugative pi electrons. Okay, do remember these electrons must be conjugative pi electrons here. Okay, so these compounds are called as aromatic compounds. Okay, these are known as aromatic compounds. Okay, well, now you guys see that here what is N here. Okay, we need to know that here. So, actually this 4n plus 2 pi electrons is here now. So, this is called as a this is called as a Hückel's rule here. So, according to this Hückel's rule, Hückel's rule, the aromatic compounds are containing the 4n plus 2 conjugative pi electrons here. So, what is n here? So, where n it may be 0, 1, 2, 3, you can keep on write like this here. And you guys see that if n is equal to 0, how many conjugative pi electrons will be there here? If n is equal to 0, it may have the 2 conjugative pi electrons. If n is equal to 1, it may have the 6 conjugative, or if n is equal to 2, it may have the 10 conjugative pi electrons. If n is equal to 3, it may have the 14 conjugative pi electrons, like that it may have here. Understood? So, this is a Hückel's rule here. And one more important thing is that, sir, what is conjugative ring? What is conjugative ring? What is a planar ring means? Very simple. If all the atoms of the cyclic rings are lies in the same plane, that is called as a planar ring. Then let us come to know what is a conjugation. What is a conjugation? Here I will explain in detail, in the most easiest way to understand the conjugation here. So, conjugation means, you please, note down these things guys here, fatafat. Well, now let me tell you what is conjugation here. So, guys, if you go with the conjugation, actually there are the different kind of the conjugative systems are there here. Let me tell you what are these the conjugative systems here. Well, to understand the conjugative systems, you must know these things here. What is conjugation? So, guys, remember conjugation means the most easiest way I am telling, conjugation means do remember separation by one single bond. Separation by one single bond is called as the conjugation here. Now, let me tell you how many conjugative systems are there here. So, we have the various conjugative systems. For example, if you see, this is one of the skeletal structures here. In this skeletal structure, what I am doing is that, so here I am writing, the pi bonds. Now, you can check that here. These are the 2 pi bonds which are separated by the one single bond. That means you can say the both the pi bonds are in the conjugation. Similarly, one pi bond and a charge. Here A is there na. A, it may be carbon atom or it may be any other atom. So, if this atom A carries a charge, now you can check that at the charge present at atom A and the pi bond are separated by the one single bond na. So, you can say the positive charge is in the conjugation with the pi bond. Similarly, so if the pi bond and a negative charge, here atom A is carrying the negative charge, this negative charge and pi bond are separated by the one single bond, you can say that the negative charge is in the conjugation with the pi bond here. And also guys, remember the conjugation may also be there between the pi bond and with the lone pair of electrons here. These are the lone pair electrons. You can see that here the lone pair electrons and pi bond both are separated by the one single bond. So, they are in the conjugation. And one more conjugative system is also there. That is the conjugation between the pi bond and one unpaired electron here. So, like that we have the conjugative systems here. So, here whatever the cyclic ring is here. So, all the atoms of the cyclic rings, means which are involved in the ring formation, they must have the continuous conjugation without any break. And what kind of the conjugative system it can be means, it can be any one of these conjugative systems. It can be any one of these conjugative systems. These conjugative cyclic rings must satisfy the Hückel's rule here. Then those compounds are called as aromatic compounds here. Now let us go with all these compounds here, and before that you guys also must know that what are the anti-aromatic compounds and what are the rules to identify the anti-aromatic compounds here. You please, if you don't complete, please make a note it here. Well, now let us see what are anti-aromatic compounds. Anti-aromatic compounds are very easy to write here. Anti-aromatic compounds are those, these are cyclic compounds. A cyclic, planar, conjugative, rings containing 4n conjugative pi electrons. How many conjugative pi electrons must be there here? So, there must be 4n conjugative pi electrons should be there here. This is called as an anti-aromatic compound here. And in this 4n is here now. What is n here? So, where n, remember n cannot be 0. n cannot be 0. If n is equal to 0, 4 into 0 is equal to 0. There is no conjugation. So, n cannot be 0, but n can be 0 in the Hückel's rule here, but not here. So, here what can be n means? N can be 1, 2, 3, 4 and so on you can write here. Then if n is equal to 1, how many conjugative pi electrons it can be? So, 4 conjugative pi electrons, or if n is equal to 2, the number of conjugative pi electrons are the 8, for 3 it is a 12, for 4 it is a 16, that means it is a multiples of the 4 here. Okay, so any compound which is satisfying these rules, okay, is called as an anti-aromatic compound. That means anti-aromatic compounds are the cyclic compounds. Okay, they are the cyclic compounds and they are planar compounds, and the cyclic planar rings are having the continuous conjugation with 4 and pi electrons here. So, if any compound is satisfying these rules, okay, this is called as an anti-aromatic. Then what is a non-aromatic means? Non-aromatic compounds are those which are, they are the cyclic compounds which are neither aromatic nor anti-aromatic. So, the neither aromatic nor anti-aromatic compounds are called as a non-aromatic compounds here. Okay, na? Understood? You please, okay, have a note of this. Okay, well, now let me tell you, okay, one more important thing to know about the stability of the aromatic compounds here, aromatic, anti-aromatic and non-aromatic compounds. So, if you see the stability of these compounds, okay, so guys here see, generally aromatic compounds are the more stable than non-aromatic compounds, and non-aromatic compounds are the more stable than anti-aromatic compounds here, sorry. Yes, so aromatic compounds are the more stable than non-aromatic compound, non-aromatic compound is more stable than anti-aromatic compound here. Okay, this is what really the important thing to understand here. Why? Because we have the application based questions. We will discuss application based questions, okay, accordingly, right. So, now let us go with some examples here. Okay, some examples. I told you now guys, who identified the first aromatic compound, that is a benzene, okay, that is Michael Faraday in the year of 1825. Now, let us see, that compound is called as a benzene compound here. So, whether this benzene is a aromatic or non-aromatic or anti-aromatic here. So, first you have to check the rules here. Yes, this is a cyclic compound, and here this cyclic compound is having the continuous conjugation. Conjugation is not breaking anywhere. So, these two pi bonds are in the conjugation, these two are also in the conjugation, these two are also in the conjugation. That means, all the atoms of the cyclic ring are having the continuous conjugation without any break here. Next, how many conjugative pi electrons are there? 3 pi bonds are there. Every pi bond contains 2 electrons. So, 3 into 2, 6 electrons are there here. So, it is satisfying the Hückel's rule. So, therefore, the benzene ring is a aromatic compound here. Okay, this is a aromatic compound here. Understood? Next, let me give you some other examples here. So, for example, guys, if I give you the naphthalene, I think everyone knows naphthalene. In our regular life, we will use the naphthalene compound as an insecticide. Okay, let us see this naphthalene here. So, in this naphthalene, you can see, so this is the polycyclic compound, which is having the more than one cyclic rings here. It is a condensed ring. 2 rings are joined with a bond called as a condensed ring. And in this condensed ring, you can check that here. Okay, here see, this is one of the ring having the continuous conjugation, and this pi bond is maintaining the conjugation in this ring also. That means both the rings are having the continuous conjugation. Okay, na? Right. And one important trick I am telling, sir, planarity is here. Sir, how to identify the planarity means? Very simple trick I am telling you guys. The continuous conjugative cyclic rings are there now. The conjugative cyclic rings from the 3-membered to 7-membered. Okay, 3-membered to 7-membered cyclic rings, conjugative cyclic rings will be the planar rings. Simple trick to remember here. Okay, 3-membered to 7-membered conjugative cyclic rings are the planar rings here. Okay, na? Do remember that. Now, you see here, this is a 6-member ring, this is also 6-member ring. So, no doubt continuous conjugation is there, 6-member rings are there. So, there will be planar rings here. And how many pi electrons are there? Total 5 bonds, 5 pi bonds are there. So, 5 into 2, 10 conjugative pi electrons are there. Since it has a 10 conjugative pi electrons, it is satisfying the Hückel's rule. Therefore, this naphthalene is also called as a aromatic compound it is. Okay, naphthalene is a aromatic compound. Similarly, let me write some other compounds like this here. Okay, this is also the aromatic compound. Okay, this is called as a anthracene. Okay, these are the polycyclic compounds which are satisfying the aromaticity rules here. So, this is called as the aromatic compound here. Okay, what is the name of this compound? This is called as a anthracene. And you guys remember, in case of the naphthalene and anthracene, the benzene rings are there, right? So, the aromatic compounds which are containing the benzene rings are called as a benzenoid aromatic compound. Okay, what are these two types of compounds here? So, these two are called as a benzenoid aromatic compound it is. Okay, you may have the questions, which of the following is the benzenoid, which of the following is a non-benzenoid aromatic compound like this here. So, the aromatic compounds which are containing the benzene rings are called as a benzenoid aromatic compound here. Okay, let me give you some other examples also here. Now, you guys here see, okay, if you see this molecule, okay, for example, Okay, this is called as a pyridine. So in this molecule you can check that. Okay, you can check that it is a cyclic ring and 6 conjugative pi electrons are there. All the conjugative pi electrons, okay, or total number of conjugative pi electrons are equal to 6. So therefore you can see, okay, this compound is a aromatic compound here. So what is the name of this molecule? So the name of this molecule is a pyridine. Okay, and is this pyridine benzenoid or non-benzenoid means remember this is a non-benzenoid aromatic compound. Non-benzenoid aromatic compound. Why? Because the reason is that it is a 6-member ring, but it is not containing the benzene ring here. Hence, it is called as a non-benzenoid aromatic ring here. And also, guys, you can understand that here in the cyclic ring, total 5 carbon atoms, 5, okay, and the molecule contains of 5 hydrogens. Also, the cyclic ring is including one, okay, nitrogen atom here. In the case of organic chemistry, remember always other than carbon and hydrogen, the remaining atoms are considered as heteroatoms. Here, that is a nitrogen, sulfur, oxygen, halogen. Generally, these atoms are called as heteroatom. Yes, here heteroatom is involved in the ring formation, and which is a non-benzenoid aromatic compound. Therefore, this compound is called as a heterocyclic. Okay, heterocyclic non-benzenoid aromatic compound here. Okay, similarly, we have some other such kind of the compounds. Let me tell you that here. Okay, for example, you guys, if you take this molecule, okay, this is the important molecule. Okay, let me tell you some important thing about these molecules here. So this is called as a furan. So this furan, okay, if you see this furan here, so it is a heterocyclic ring because heteroatom is involved in the ring formation, and in this ring 5 atoms are there. So therefore, this is a 5-membered heterocyclic ring here. Now let us check that whether it is aromatic or not here. You guys here seeing here, these are the 2 conjugative pi bonds, and the oxygen atom is not having the pi bond, but oxygen atom is having the lone pair of electrons here. These lone pair of electrons are maintaining the conjugation with both the pi bonds here. So therefore, you can say that all the 5 atoms of the cyclic rings are having the continuous conjugation. And one important thing you should remember, okay, the conjugative lone pair of electrons, conjugative lone pair of electrons or conjugative negatively charged pair of electrons are always considered as the conjugative pi electrons here. Why? Because these lone pair of electrons are involved in the resonance formation. After the resonance, okay, after the resonance, you can see, okay, these pi bond electrons are converting into the lone pair electrons are converting into the pi bonds here. Correct? So, see here how this pi bond is forming because of this lone pair of electrons. That means lone pair of electrons are converting into pi bond electrons. Hence, the conjugative lone pair of electrons, conjugative negatively charged pair of electrons can be considered as pi electrons here. Okay, this is the first thing to remember. And second thing is that one atom here, this oxygen atom is having how many lone pairs here? 2 lone pairs are there. So one atom, heteroatom, it may have the 1 lone pair or more than 1 lone pairs which are in the conjugation. But remember always, so that atom can contribute so only 1 lone pair of electrons in the conjugation here. That means here oxygen is having the 2 lone pairs, even it is having the 2 lone pairs, it can contribute the only 1 lone pair for the conjugation. So therefore, now in this molecule we can count the total number of the conjugative pi electrons here. How many conjugative pi electrons are there here? Here these are the 2 electrons of the lone pair plus 4 electrons from the 2 pi bonds here. So total 6 electrons are there. So since it is having the 6 conjugative pi electrons, it is satisfying the Hückel's rule. Therefore, this is a aromatic compound here. And this aromatic compound, is it containing the benzene ring? No. So therefore, this is called as a non-benzenoid. Okay, non-benzenoid aromatic compound, and which is a heterocyclic compound. It is okay. It is a heterocyclic compound. So this is a 5-membered cyclic ring. It is a heterocyclic compound here, and this heterocyclic compound is an aromatic compound without benzene ring. Hence, it is called as a heterocyclic non-benzenoid aromatic compound here. Okay, like that we have some other examples also to discuss. Okay, let me tell you those examples here. So for example, you guys, if you see this molecule, okay, so this is called as a thiophene. Okay, thiophene. So in this thiophene also, oxygen is containing the 2 lone pairs here, but out of the 2 lone pairs, 1 lone pair is in the conjugation. So therefore, total it is having the 6 conjugative pi electrons. So it is also having the same properties like a heterocyclic non-benzenoid aromatic compound here. Okay, now understood? Let me give you some other molecules here. So if I give you some other molecules, okay, like you can see this here. Okay, so this is called as a ferrol. So this ferrol is in which nitrogen is there. So nitrogen is having the lone pair of electron. So this lone pair of electrons are maintaining the conjugation with the 6 conjugative pi electrons. So therefore, this ferrol is also okay a heterocyclic non-benzenoid aromatic compound here. Okay, this is a heterocyclic because heteroatom is involved in the cyclic ring formation. So this is a heterocyclic, which is a non-benzenoid aromatic compound it is. Okay, right. Let me give you some other compounds here. Okay, so you guys see that here. So for example, if I give you this molecule, so this is called as a cyclopentadiene, 1,3-cyclopentadiene here. Is this aromatic, anti-aromatic, non-aromatic? Means you can check that here. Cyclic ring is here. So in this cyclic ring, conjugation is here, but it is not continuous conjugation in the entire ring. Why? Because the conjugation is here from here to here only, but the conjugation is breaking at this carbon atom. That means this is a non-conjugative cyclic compound here. Always remember, simple thing I am telling you, the non-conjugative cyclic rings are the non-aromatic compounds. Okay, do remember, non-conjugative cyclic rings are the non-aromatic compounds here. So therefore, this is a non-conjugative cyclic ring. Okay, so therefore, this is a non-aromatic compound. Okay, non-aromatic. Why? Because the common sense we can apply here. Aromatic compounds are the conjugative cyclic rings. Anti-aromatic compounds are also conjugative cyclic rings. But here it is a non-conjugative cyclic ring. Therefore, this is neither aromatic, okay, nor anti-aromatic, but it is a cyclic compound which is called as a non-aromatic compound. Like that, easily you can identify here. Now let me tell you some other molecules here. So here it is a non-aromatic because of the loss of the conjugation. Correct? No? Because of the lack of the conjugation here. Now let us bring this carbon into the conjugation by generating the charge. So for example, if I generate the positive charge here by reacting with the active metals, okay, if I generate the positive charge, yes, it is coming into the conjugation now. This carbon is coming into conjugation because the pi bond, okay, these pi bonds and positive charges are separated by the one single bond in the both the directions. So therefore, they are in the conjugation. Now here it is a conjugative cyclic ring here, and all the atoms are having the sp2 carbons. sp2 carbons are there, no doubt it will be the planar ring here. So with the 5-member cyclic rings. Okay, na? Right. Okay guys, now you can check that how many conjugative pi electrons are there here. Only 4 conjugative pi electrons are there. Here positive charge means there is no electron, but here 2 conjugative pi bonds are there. Every pi bond contains 2 electrons. So 2 plus 2 is equal to 4 electrons here. So 4 conjugative pi electrons are there. So it is satisfying the 4n pi electron rule. So therefore, this is a anti-aromatic compound here. So what is this here? This is a anti-aromatic compound. So you guys see that this is called as a cyclopentadienylium ion. So this cyclopentadienylium ion is a anti-aromatic compound here. Similarly, suppose what happens if I bring this conjugation, by generating the negative charge here. If I bring the conjugation by generating the negative charge, what happens here? So I told you that here this carbon is maintaining the conjugation with the negative charge and the pi bonds here. Now one negative charge is equal to how many electrons? Means you should consider one negative charge is equal to the 2 electrons here. Okay, na? Right. Now these are the 2 electrons, and here total 4 electrons, total 6 conjugative electrons are there. So it is satisfying the Hückel's rule here, and it is a 5-member cyclic ring, is a planar ring here. So therefore, this is a aromatic ring here. Okay, this is aromatic ring here. So now guys, here what I am doing is that I am giving, okay, the numbering for all these 3 compounds here. Consider this is compound A, okay, compound B and compound C here. So if I label these compounds with A, B, C here, can you tell the stability order of these compounds here? So if you go with the stabilities, generally I told you that aromatic compound is the most stable. Here aromatic compound is a C, is a more stable. Then non-aromatic compound. What is the non-aromatic compound? Non-aromatic compound is a. Non-aromatic compound is more stable than anti-aromatic compound, that is B. So if these 3 compounds are given, and if they are asking you to write the stability, you must follow this order here. Understood? So please note it down for apart. Okay, well, now let me tell you some other important examples like this here. Okay, for example, if you take this molecule, okay, this is called as a cyclopropene, and here this carbon is missing the conjugation. So this is a non-conjugative cyclic ring, therefore this is a non-aromatic compound. Okay, this is non-aromatic compound. Now if I bring that carbon atom into the conjugation by generating the charge like the positive, or by generating the charge like the negative here. So what is the nature of these compounds here? You can check that here. Here conjugation is here, and number of the conjugative pi electrons are the 2 conjugative pi electrons are there, satisfying the Hückel's rule. Therefore this is a aromatic compound, and here it is having the total 4 conjugative pi electrons, which is satisfying the 4n rule here. So therefore here this compound is called as a anti-aromatic compound here. Okay, this is a anti-aromatic compound. Now you guys, if you go with their stability orders, so for example consider, okay, this is a first compound, this is a second compound, this is a third compound, and if you find, okay, if you have the question to find the stability order here, so we know that aromatic compound is a more stable than non-aromatic compound. Non-aromatic is a more stable than anti-aromatic compound. So this is the correct order of the stability here. Okay, like that you need to answer the question. You need to identify aromatic, anti-aromatic and non-aromatic compound. Now let me tell you some other important examples here. So for example guys, here if you see this molecule, you can check this molecule here. This is called as a cycloheptatriene. Okay, 135 cycloheptatriene here. You can give the numbering like this here. So after giving the numbering, you can write it as a 135 cycloheptatriene. And is it aromatic, anti-aromatic, non-aromatic means? So here the 7th carbon is missing the conjugation. So therefore this is a non-conjugative cyclic ring. I told you that non-conjugative cyclic rings are the non-aromatic compounds here. This is a non-aromatic compound. Now if I bring that 7th carbon into the conjugation by generating the charge, let's see how its nature will be changes here. Suppose if I generate the positive charge here, now this carbon is coming into the conjugation with all the pi bonds here. So now it is the conjugative cyclic ring with the 7 atoms in the cyclic ring. Therefore no doubt it will be the planar ring here. And this is called as a tropylium ion. Okay, do remember the name of this ion is a tropylium ion. So this tropylium ion contains a 6 conjugative pi electrons here. See here positive charge means there is no electron, and here 3 conjugative pi electrons, conjugative pi bonds are there, 3 into 2, 6 electrons are there. So therefore this is a non-benzenide homocyclic aromatic compound here. Okay, homocyclic aromatic compound here. Now what happens if I generate the negative charge, or if I generate the negative charge at this carbon atom to bring all the pi bonds into the conjugation. So when I generate the negative charge here, now it is also a 7-membered conjugative cyclic ring. So no doubt it is the planar ring, but which is having the how many conjugative pi electrons here? 8 conjugative pi electrons are there. So therefore this is a anti-aromatic compound here. Okay, so now suppose if I ask you guys to arrange them in a increasing decreasing order of the stabilities, now we can do that now here. For example, consider this is a compound A, this is a compound B, and this is a compound C. So if you go with the stability order, how will be the stability order here? So aromatic compound is the most stable, that is a tropylium ion is a B. Okay, is the most stable. Then non-aromatic compound is a A, and then it is the most stable then compound C. Okay, like this we have to write the stability orders here. Let me tell you some more important aromatic compounds here. Okay, hope you are understanding. Okay, please, okay, have a note of this here. Next, you guys can see some other molecules like this here. Okay, so here this is called as the interesting molecule and the important molecule also here. Okay, to write. Okay, see guys. So for example, if you take this molecule, this is called as a trophone. So this tropone is here now. Okay, this is called as a tropone. Is it the aromatic, anti-aromatic, or non-aromatic means? Let me tell you here. Suppose if the XO double bond is here, what do you do is that if XO double bond is here, write the polarization of this bond here. So here, okay, as oxygen is a more electronegative than carbon, oxygen will take the electrons from the carbon atom. After taking this electron, okay, what happens here at this carbon? Okay, at this carbon, a positive charge will be generated. Here, oxygen is taking electron, so it gets a negative charge and generates a positive charge at this carbon atom, and that positive charge is bringing this ring into the aromaticity. So therefore, okay, this trophone is the aromatic compound here. Okay, this is the aromatic compound here. Like this, let me tell you some other molecules also here. So for example, you guys, if you see this molecule, okay, in this molecule, okay, let me write one XO double bond here. So when I write this XO double bond, okay, what happens, you know, okay, if more than poly rings are there, if at least one ring is aromatic, the compound will be aromatic. Do remember that here. And in this ring, if I polarize this bond towards this 5-membered cyclic ring, okay, then what happens here? So here, okay, you will get this kind of the charges. Okay, in this kind of the charge, what happens, you know? Okay, let's see that here. What happens here? You guys can see this molecule like this here. Okay, after bringing the charges by the polarization of the bond, okay, by the polarization of the bond, here now at this carbon the positive charge is generating, at this carbon negative charge is generating, and also it has the conjugative pi bonds here. Now you can say this is the aromatic ring, this also aromatic ring, so therefore this compound is also aromatic ring. It means suppose if they are giving the polycyclic compounds with the XO double bonds, okay, do the polarization in the proper direction and check that if any ring is getting the aromaticity, no doubt the compound will be the aromatic compound here. Okay, now understood? Right. Let me tell you some other kind of the compounds here. So for example, if I give you this molecule, this is called as actually these are the polycyclic compounds here. In this polycyclic compound, if you take this molecule, okay, this is called as a biphenyl. In this biphenyl, both the rings are individually, how to check that here. This is an aromatic ring, this is also the aromatic ring here. So therefore, this biphenyl is also, okay, a aromatic compound here. This is a highly carcinogenic agent here. And you guys can see this, okay, for example, if I give you this kind of the molecules, so this benzene is an aromatic compound. If any substituent is there here, so whatever the substituent, I am writing as a G group, whatever the group it means there, so but here the ring is having the aromaticity, so therefore this compound will be the aromatic compound. So suppose if you write the halogen here, halobenzene, hydroxy group, phenol, aldehyde, benzaldehyde, if you write the carboxylic acid, benzoic acid, all these are the aromatic compound. The reason is, okay, the ring is aromatic ring is already present in the compound here. Understood? And suppose sometimes the students are getting confused with these kind of the molecules, okay, these kind of the molecules here. You need not to confuse with these molecules here. Okay, sir, is this aromatic or not? Means absolutely it is aromatic, because here one of the ring is aromatic, so therefore the compound will be the aromatic compound here. Okay, like that you can identify the aromatic, anti-aromatic, non-aromatic compounds in the most easiest way here. Understood, guys? Let me tell you some other important examples here. So for example, if I write this molecule, okay, if I write this molecule, okay, tell me guys whether it is aromatic or anti-aromatic or non-aromatic. Means it is a conjugate to cyclic ring here, so which is having the 4 pi electrons here. So 4 pi electrons okay, is there, so therefore, okay, this is called as a anti-aromatic compound here. Okay, this is called as a anti-aromatic compound here. Now for example, if I give you this molecule, okay, this molecule is having the only 2 conjugate to pi electrons, okay, not conjugation, there are the only 2, okay, pi electrons are there, and this is a non-conjugate to cyclic ring. Non-conjugate to cyclic rings are always non-aromatic compounds here. And now here, suppose if I generate the charges, here, okay, now here you can see this, okay, this molecule is having the continuous conjugation in okay, all the atoms of the cyclic ring, and number of the conjugate to pi electrons are the 2. So therefore, since it is satisfying the Hückel's rule, okay, this is called as the aromatic compound here. Now for example, guys, here, suppose if I generate the 2 negative charges here, if I generate the 2 negative charges here, so then what happens here? 2 negative charges means total, okay, 6 conjugate to pi electrons are there. So therefore, since it is having the 6 conjugate to pi electron, so this compound is also called as the aromatic compound here. Understood, guys? Hope you are understanding all the compounds very easily. Okay, so please note down these examples fatafat. Okay, done. Now you guys see that okay, so annulenes are there. So what are the annulenes means? Okay, very simple. Annulenes are those compounds which are having the CN-HN general formula. So the hydrocarbons which are having the CN-HN general formula generally called as annulenes, and always remember annulenes are the monocyclic compounds. Okay, these are the monocyclic okay, compounds here. The monocyclic compounds having the CN-HN general formula are called as the annulenes here. So generally, how to write their IUPAC names? Whatever the number of carbons are there, write the number, okay, of that carbon atoms in the square brackets, then add a word annulene here. So you will get the name of the annulene here. So generally, okay, in case of the annulenes, suppose if the 4 carbons are there, that is called as the 4 annulene in the cyclic ring here. So the 4 annulene is here. So 4 annulene means you can write it like this here. So it is the monocyclic conjugative, okay, ring it is. Okay, this is a monocyclic conjugative ring with the 4 carbon atom. Hence it is called as the 4 annulene. Suppose if the 6 carbon atoms are there in the cyclic ring, okay, that is called as 6 annulene. Whatever the benzene we are calling it here. So this is also called as the 6 annulene here, because it is a monocyclic conjugative ring here. Monocyclic conjugative rings of the CN-HN molecular formula are called as annulenes here. So while you are writing the name of those molecules, you write the number of carbons here. And one important hint I am telling, in case of the annulenes, how many conjugate to pi electrons are there means, in case of the annulenes, number of conjugate to pi electrons are equal to number of the carbon atoms in the cyclic ring here. So here number of the conjugate to pi electrons are the 4, here number of the conjugate to pi electrons are the 6. So since it is having the 4 and conjugate to pi electrons, okay, this is the anti-aromatic compound. Since it is having the Hückel's rule, satisfying the Hückel's rule, so this is the aromatic compound here. Okay, easily you can identify the annulenes whether they are the aromatic or anti-aromatic like this here. Okay, you please fatafat note it here. Okay, done. So now let me tell you one most important the annulene here. Okay, that is, okay, you can see 8 annulene here. Okay, 8 annulene. So what is this 8 annulene, and what is the structure of this 8 annulene here? This is really a very important example here. So we can write the 8 annulene like this here. This is called as a cyclooctatetraene. Okay, cyc 1357 cyclooctatetraene here. So, this is 8 Annulene. So, in this 8 Annulene, okay, generally it is having the how many pi electrons means 8 conjugative pi electrons are there. So, what we can consider is that this is considered as a anti-aromatic compound we can consider, but you guys remember this is not anti-aromatic compound. So, this is a non-aromatic compound here. Let me tell you why it is a non-aromatic compound. The reason is that this is a non-planar ring it is, okay, and which ring it is? This is a non-planar ring here. Then what is the shape of this molecule means? Okay, the molecule, okay, will be in the tub shape like this here, okay, the molecule will be in the tub shape like this. So, in this tub shape, if you observe that, so here are the 4 carbon atoms, okay, these 4 carbon atoms will be in the same plane, okay, these 4 carbon atoms will be in the same plane here, and the remaining 4 carbon atoms are out of the plane. So, here it is missing the planarity. So, therefore, this is a, okay, this is not a anti-aromatic compound, and here will be the pi bonds. So, pi bonds can be written here. So, this is called as an anti-aromatic compound here, okay, this is called as a 8 Annulene. Not only 8 Annulene, remember 10 Annulene is also anti-aromatic compound here, okay, this is also anti-aromatic compound, and you guys remember, okay, 14 Annulene is here now. So, 14 Annulene is the aromatic compound, okay, 14 Annulene is a aromatic compound here, okay. So, this is what, okay, you have to understand about the aromaticity. Thank you guys, okay. So, please stay in contact with us, okay. If you guys really wants to, okay, learn the subjects in detail, you guys, okay, can join at the chemonics classes, okay, because we are taking the regular classes, okay, the batch wise. So, we are the classes are going on. If you are anybody is interested, you guys please contact me at this number. So, my contact number is at, okay, 9342468778. You can contact me at this number, or also you can contact me at 93424 okay, 57593. So, these are my institution numbers, my contact numbers here. You guys, if you want the regular classes, okay, with a in detail explanation, okay, to improve your knowledge, please feel free to contact. So, I am your, okay, DPK sir. So, I am your chemistry faculty. Thank you guys.